Okay guys, in this video I will continue with 3.2. So 3.2 is about solving quadratic equations. You just need to know that quadratic equations are related to parabolas, okay? So let's just first start with how to solve them. Okay, so I'm going to write it like this. You can actually you can actually have two types of quadratic equations. Okay, first of all, you got x squared plus 6x. Let's just look at this quadratic equation, and let's also look at this one, x squared plus 9x plus 14. Okay, so this is not a formula yet because there's only actually one x in both of them. So you can just say, hey, factorize. The word we're looking for is factorize. You got two types. This one where you take out you look for a factor that you can put outside of the brackets. So you see an x over here and an x over there. So that one you can take out. What you have left is x, because x times x becomes x squared, plus the 6. This is factorizing. And then you're done. Factorize this one, well, this one you do with the product sum method. So we talked about it in class. It means that you're looking, when you add two numbers, you get the 9, and when you multiply, you get the 14. So there are many ways to try this. You can make a table over here. Okay, let me find out what times what makes 14. So you got options. You got 14 times 1, 1 times 14, 7 times 2, 2 times 7, and I think that we have all of it. But you know, when you add them, you should get 9. So you get here, let's look, only when you have this or this, you get 9. But both of them are positive. So the way you're writing it, if you first start with the 7 or then with the 2, that doesn't matter. So indeed, this one will become, starting with the x over here, plus 7 plus 2. Now, when they say solve, and that happens also in theory E already. So theory A, it's already solving. But for HAVO, they're not solving yet. So that's later. HAVO, it's only factorize. But let's have a look. So when you need to solve now, let's just take another one. Let's work with another example. Let's look at 8x squared plus 16x. And for the product sum method, let's do something difficult. Let's work with x squared minus 5x minus 6. All right, so now we're gonna solve. So I say this one is equal to 0. We're gonna solve for 0. This is very important. We're gonna see later why. So look for the factor that you can put outside of the brackets. If you do only x, there is an 8 left behind and a 16. You can take more. So if you do 8x, which is great, you are left here with an x, and then you are left here 8x times 2. So this is the right way. Now we're gonna solve. There is something you should know. That's a theory. They are explaining also that a times b becomes 0, which means a will be 0 or b will be 0. So this is the a, this is the b. So you get 8x is 0. X will be, of course, 0 divided by 8, 0. Or the x plus 2 is 0. Of course, what should x be? Minus 2 plus 2 will be 0. So x will be negative 2. So you found two solutions. Now let's look at this one. This is the product sum method. Okay, let's try it without writing it down. Let's just try it. What times what makes negative 6? Okay, we know that 3 times 2. Also, we know, so we have, let's say we have negative 3 times 2, that makes minus 6. We have negative 2 times 3, that makes minus 6. We also have, if we would think, let's say, for example, negative 5 times 1. No, because negative 5 times 1, that will become negative 5, so that's a no. But negative 6 times 1, that's a yes. And also, minus 1 times 6. But then, yet again, let's have a look. When you add them, you must get negative 5. So let's see. Minus 3 plus 2. No, that's negative 1. Minus 2 plus 3, that's 1. Minus 6 plus 1, hey, that gives me negative 5. And minus 1 plus 6, that is positive 5. So that's a no. So we're going to stick with negative 6 plus 1 equals 0. Now, we use the same method. This is the A, this is the B. So we get x minus 6 is 0, or, this means or, x plus 1 equals 0. X will be negative 1, x will be positive 6. We found those two solutions. Now, very important, what are we actually doing? If you can solve this, okay, that's really great. You can work on the exercises, okay, you can solve it. But what are you doing? What are these things? What are we actually solving? Now, and this is where it gets interesting. Remember, there's also more. There's also with brackets, the equations, and you also get with fractions. And there are also where you have to big numbers and then you have to divide. And yeah, the simplifying the fractions. And I think, Fabio, if I have a look in here, you have the same thing. Yeah, you have the same thing. So remember, these are also things you should know with the brackets, when you have big numbers, how to solve for 0. Also, remember, note, you can only solve when it's equal to 0. So for example, if you would have this one equals 16, always remember, bring that to the left side. And then you see, hey, I don't have this one anymore. I have the product sum method. Yeah, so always remember, you can only solve when it's equal to 0. Very important, write it down. You can only solve equations when it's equal to 0. Okay. Now, let's have a look. Let's save this up here. I don't want to lose that. So I hope you can still see it. Yes. Okay. So I'm going to copy this here. But now I'll create formulas. So for example, y equals x squared plus 16x. And another one, y equals x squared plus 9x plus 14. What are you actually doing? You're saying it's equal to 0. What is 0? You actually put the y for 0. It doesn't matter if you write it on the left side or right side. So what you're doing is y is now 0. Here as well, y is 0. And then you solve, and then you get, this is what we did already, you get x is 0. Or x is negative 2. So you get coordinates 0, 0.0 and another coordinate negative 2, 0. Here we did the same thing. Remember, we found out after calculating x is 6 or x is minus 1 because we put for y 0. You get also coordinates here 6.0 and the other coordinate will be negative 1, 0. So what you actually did, let's make a graph. Let's make the parabola here, x and y. What you actually did was finding, dun, 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 x-interceptions because negative 1, 0, and over here we got 6, 0. And then you can find a way to find the top. But it's negative 1, 0, 6, 0. So you find what are these x-interceptions. What is this? Also x-interceptions. So this is the theory E from HAVO. That is what you're doing. When you're solving an equation and the y becomes 0, you get the x. That means you're looking for the x-interception of the parabola. You know this is going to be a cup. So probably I'm just making something up right now. And also you know already that the x that's going to be the top, it's going to be 3.5. You know that already. But is this going to be a cup? And this one, it's also going to be a cup. And when you make a sketch of that one, it's over here. And the other one is minus 2, 0, which will be over here. And the top, it will be, I have to make something up, but it will be like this. Yeah, because it's also a cup. So this is about the x-interceptions. Now, what about the y-interceptions? So we're going to shift it up. This goes away now. This is x-interceptions. So x-intercepts on a graph. Actually, what are we doing? And now let's go to the y-intercepts. That's more easy. The y-intercept is actually fill in x is 0. So this one, we're going to fill it in. Y will now become 8 times 0 squared plus to the power 2 plus 16 times 0. You calculate, you get 0. So the y-intercept of this one, it's going to be 0.0. So that means indeed, where you see it over here, it's going only through that point. So we made a pretty good sketch. It's never over here, it's not intersecting the y-axis anywhere else. Let's try this one. Fill in x is 0, and we get y 0 squared plus 9 times 0 plus 14. You calculate, you get 14. You always get C. You always get C when you have this writing, this form of the parabola. And then y-interception, okay. I see that my sketch is not really that cool, but the y-interception in this case 0.14. Now I'm starting to wonder if I perhaps made a mistake, but I don't think so. Oh yeah, I know, I see it. We're not using that one. So excuse me. This is of course a different one. I was looking at this one, so let me just correct myself. This is very important. Let me correct myself. This is not the formula. We were looking at this one. My bad, guys. Of course, we were looking at this one. And then when I try to write it down here correctly, excuse me, guys, 0 squared minus 5 times 0, and then minus 6. You get eventually the C minus 6. And that makes more sense because over here on the y-axis, we get negative C. Yes, I found the mistake. And I hope you guys managed to find that too. So, conclusion, x-interceptions are related to solving equations the way you're used to with the beginning, the first part of the formula equals 0 because you're filling in for y 0. And the y-interceptions, that is just filling in for x is 0. It's also an equation, but this is something you've done many times before. So these are the y-interceptions. Therefore, we can finish with 3.2. Remember that also when you're working on a graph, a bridge, something like that, y-interceptions are often for the height of a bridge or a tunnel or whatever. And x-interceptions are always about a width, the width. Yeah, about a width of a tunnel, the width of something, the starting point, whatever.